Hello everyone. Previously we had discussed on the this one, reversing a linked list algorithm, right? So today we'll be discussing on the topic detect and removing the loop in the linked list, right? So algorithm basically. So let's get into the definition part first. Then we can discuss the this one. Then we can just go with the explanation of the algorithm, and then we can finally write the code, right? So first let's get into the definition part. So what is a loop? Basically a loop in the linked list occurs when a node's next pointer points to the previous node, creating a cycle. So this one term is very important, right? A loop in a linked list occurs when a node's next pointer points to the previous node, creating a cycle. So detecting and removing this loop is crucial to prevent infinite traversals and memory issues, right? Again, detecting and removing this loop is crucial to prevent infinite traversals and memory issues, right? So this is fine, I believe. So the next part here would be let's get into the explanation part here, right? So just give me a second, 1 second here. I'm just yeah, this is fine. Yeah, let's move on with the this one, what do we call explanation part. So one of the common approaches here in the Floyd cycle detection is the Floyd cycle detection algorithm, also known as tortoise and hare algorithm. So I have explained this one, so this is very important. So we'll be making use of it most of the times in many problems, right? So you have to know this algorithm at any cost, this one, Floyd cycle detection algorithm and the linked list, right? So this is very important, man. It's very simple, right? So we'll be going with the slow and fast pointers, basically that's it. So just if you don't know that, you can just go through that one. See here, this one, the first one, 28. See here, Floyd cycle detection algorithm. So I'll be uploading the same thing in the GitHub also. You can just refer the GitHub. You can just go to the this one, go through the video that I have uploaded, right? Anything works, whatever works for you, right? So this is fine. So let's see the algorithm, what we'll be doing. So we will be making use of the two pointers. One is slow and another one is fast, right? So slow pointer, it moves one step, and the fast pointers, it moves two steps basically. If there is a loop, slow and fast will eventually meet. Just remember this one, this is very important. If there is a loop, then slow and the fast pointers will eventually meet, right? If there is no loop, then it will not meet, right? So to remove the loop, we will find the start node of the loop and we will set the previous nodes next to the none. So this point is very important. To remove that loop, what we'll be doing, we will be finding the start node of the loop and we will set the previous nodes next to none, right? So this is fine, I believe, right? So this is fine. Next, let's do one thing. Let's go with a what do we call, let's move on with the algorithm part, right? Let's move on with the algorithm part, right? So first thing here would be, let's go with the node man. So just give me a second here, 1 second. Yep. First, as usual, let's go with the node here. So this one will be class node. So within the node class, so we have to store the nodes value as well as we have to go with a pointer to the next node, right? So I'll just go with here data. Also, 1 second, what I'm doing here. So yeah, sorry man, I was just practicing in Java, so I'm writing in Java itself. Sorry. So this one is fine. Let me go with the initialization part. We have to go with it. So I forgot that I'm writing the code in Python itself. So this is fine. So I practice in both again, Python and the Java, right? So this is fine. So I'll just go with the data here. So within the initialization part, the first thing is we have to store the nodes value, right? So I'll just go with self dot this one data. So let me assign this one to the data. So this is fine. So the next step would be, let's go with a pointer to the next node, initially none. Let's set this one to the this one, self dot next. So this one equals none. So this is fine. So next, let's do one thing. Let's go with a class linked list man. So I'll just go with linked list. So I'll just go with a linked list. So this is fine. Now let's go with the initialization part. First thing, I'll just go with def here init. So this is fine. Yep, let me assign head to the this one none. We are at the start of the linked list basically, right? So we have assigned the head to none here, so this is fine, I believe, right? So next what I'll be doing, let's go with the append helper method, or the this one, what do we call, function, right? So I'll just go with def append. So this one, let me pass self and data, so I'll just go with self and data. Also let me go with a new node, so this is fine. This one will be node of data, so I'll just pass data here, this is fine. So I'll just go with here if not self dot head, this is fine. Then what we will do, let me assign head to this one new node, right? So this one new node, this one is fine. Let's return something. So first let's do one thing, let me assign last to head, so this is fine. Yup, now let's go with the while loop, so this one will be while last dot next, while of last dot next, then we have to assign the last to last dot next, so I'll just go with last dot next, as we are going with a this one append function, right? So last dot next, or the append method, so this is fine. Now I'll just assign the last dot next to the this one new node, so this is nothing but the new node here, simple, right? So now let's do one thing, let's go with the one more function, naming create loop here. So this is the function to create the loop for testing, so I'll just go for def create loop. So this one, let me pass self as well as the position here, right? So if position is 0, if the position, if it is equivalent to the 0, then let me give return here, so this is fine. Also let me go with loop start, so this one, let me assign this one to the head, this is also fine, man. So let me go with a simple for loop now, for in range, so this is fine. So this one position -1. Now let me assign the loop start to the loop start dot next, so this one will be I have given loop start, this one again loop start dot next, so this is fine. We have to assign end to the head as well now, end to the head. Yep, now we are done with this part. So again I'll just write one more this one, what do we call, so this is fine, right? So what is the error that we are getting here? Head is not defined, so here I have considered position, this is fine. Equals 0, I'm just going returning, this is fine. Loop dot start head, this one is one in range, position -1 I have considered, this is also fine. Loop start dot next, end equals self. Oh, this one self I have not made use of, directly I have given head. I'm not thinking of this one anyway. This, it has to work correctly now. So let me go with a while loop again. So this one while, we have while of end dot next. So next what we will do here, so let me assign the end to end dot next, so this one will be end equals end dot next, so this is fine, man. So the finally we have to create the loop, so this one will be end dot next equals loop underscore start. So now we have to detect the loop using the Floyd cycle detection, right? So let's write the final function here. So also we'll be going with a print list to print the list, that is different thing. So this is the main this one, what do we call, main function. So let's write the let's go with the detection of the loop using the Floyd cycle detection, right? So I'll just go with def here. Sorry, so this has to be detect and remove loop. So let me go with self here. This is fine. Let me assign slow to fast. So this one will be self dot head. Yep, the first step here would be the while loop. So we have to detect the loop, right, first. So let me write the while here, while of slow and so fast and fast dot next. To write the Python, I'm not gonna lie, to write the Python code, so you don't need the coding skills actually. You should be knowing the English pretty well, that's it. So I'm not gonna lie, and I'm not even making fun of Python here. So you have to know English pretty well, that's it. This is as simple as that. So this while slow and fast, this one, and we are considering fast dot next as well. So this is nothing but the Floyd's detection algorithm, right? So we have already discussed this one. Let me assign the slow to slow dot next. So let me write this one very quickly, and fast 2 steps ahead, right? It will move 2 steps, right? Slow 1 step and the fast 2 steps. So I'll just go with fast dot next. So this is fine as well. This one, if slow equals fast, then let me print loop detected at node. This one is slow dot data. This is also fine. So let me give break here. This is fine. Now let me go with else here. So this is fine. Else what we'll do, we have just for the interactive purpose, I'll just give something in the print, something within the print. So no loop detected, something like that, right? So I'll just give no loop detected self. This is fine. Yep. The next part would be, so I'll just give return here. So this is fine as well. Yep. Yep. Now let's move on with the next step, the step 2. So we have to find the start of the loop, right, if there exists a loop, right? So I'll just go with slow equals head. This is fine. Let me assign previous to none, and also let me write the while loop here. So this one, while slow shouldn't be equal to fast, right? So this is fine. Then let's set the previous to fast. Also let me set the slow to slow dot next 1 step, and finally fast to fast dot next. So this time it will be only fast dot next. So this is fine, man. Yep. Yeah. Now let's move on with the next step. Let's move on with the, oh, what happened to here? Oh, I missed this one, man. So let me go with we have, let me leave this one. So why this previous, what happened to this one? Previous is not accessed. Why previous is not accessed here? We have made use of the previous, we have assigned the previous to this one, right? So we are going with, give me a second here. So this is fine. Let's move on with the next step. So let's if the cycle exists, right? So now let's do one thing. If the cycle exists, then we have to remove the loop, right? So we have, for removing the loop, as I've said, I'll just assign this one previous dot next to none, and also let's print something for the interactive purpose. So I'll just give here loop removed. So loop started at node, this is also fine, and this will be slow dot data. So this will be slow dot data, this is fine. Yep. Now let's print the linked list. We have to print the linked list, so this one will be df print list. This one will be print list. Let me go with a self. This is also fine. So let me go with current. So let me assign this one to the self dot head. Yep. So let me go with the while loop here. So this one will be while of current. So this is fine, while of current. Let me go with the print here. This is fine. So this one will be current dot data, and also let me set the end to this one. Let me give arrow mark here so that this looks good. That's it. So let me assign the current to current dot next here. Finally, what we need to do, let me print none here, just for the interactive purpose. I'll just print none within the strings, right? So this is it for the algorithm, main algorithm, right? So let me do one thing. What happened here? Is not accessed. Why this one is showing not accessed? So let me format the document once. So this is fine. Let's go with the example usage, and then yeah, let's go with the example usage. I'll just consider ll, nothing but the linked list. Let me call the linked list class here. So this is fine, man. Next part would be, so let me consider for loop for I in range, and the range let me go with 1 to 7, basically within the range 1 to 7. So I'll just make use of the append method that we have written, or the append function, helper method, or the function that we have written, right? So this one is I. Finally, let's create the loop connecting the last node to the node with a value 3. So we are going with the range 1 to 7, right? So let's create a loop that is let's create a loop connecting last node to the node the value 3. So this will be linked list dot create loop. So this one of 3, right? So this is fine, man. This one will be linked list dot detect and remove loop. So this is nothing but the function, and linked list dot print list. So this one will be print underscore list. This is fine. Yep. So now let me format the code once. So we have successfully written the code or the algorithm along with the example usage, right? So the output that we need to get here is loop detected at the node 5, right? So here we are creating the loop at 3, right? So basically we have to get the loop detected at node 5, and second line we have to get loop removed, that loop started at the node 3, right? So this one loop removed, loop started at the node 3 we have started, right? So see here we are creating a loop at node 3. So this is fine. So final output that we need to get here is 1 2 3 4 5 6 none, right? So this is fine, right? So 1 2 3 4 5 6 7, basically index 0 1 2 3 4 5 6, basically, right? So we are removing the this one loop. Actually loop is detected at the node 5, and we'll get loop removed, loop started at node 3, and finally 1 2 3 4 5 6 pointing to the 6 pointing to tail, nothing but the none, basically, right? So this is the output that we need to get here. So let me do one thing. Let me give control J here, Python. So let me copy this one entirely dot py. So this is taking time, man. What happened? So what happened to this one? Process ID PID 1356 command line. The following extensions want to relaunch the Python. Oh, just give me a second. So what mistake I have done here is in the line number 29. See, I have just given last dot next here. So we have to assign this one last to the last dot next. This is fine. The next part here would be in the create loop function. So this one we are going with the end dot next equals loop start. This is fine, but there is an indentation problem, right? So we have to move this one here. So let me format the code once. Now let me run this one. Let me give clear screen here. So this is fine, man. Loop detected at the node 5, loop removed, loop started at the node 3. This we are getting correct. So this one, the final one we have to get here, this one 1 2 3 4 5 6, right? So that one we are not getting, basically the linked list. This one 1 2 3 4 5 6, none. Basically we are considering this one I to range. So what we have done wrong? So there is something wrong with the print list method actually. Let's see what is wrong. So basically again this is also indentation problem. So this one print list we have to move here, right? So this is basically the function or the helper method. So this one has to be with the same thing, right? So this is fine. So I had to just move out this one. This is fine. Let me give clear screen here. Let me run this one again. Python, yeah. So here now we are getting the correct output. Loop detected the node 5 and loop removed, loop started at the node 3. That's what we have done here, right? So this is also correct. So 1 2 3 4 5 6, so this one, this is fine. We are just printing the list, right, after removing the loop. So this is 1 2 3 4 5 6 and the 6 pointed to the tail, nothing but none here. So this is fine. We are getting the correct output basically. Right? So here loop detected at the node 5, this output, this is nothing but, so the slow and the fast pointers meet at the so they have met at the node 5, basically confirming the loop exists, right? So this is fine, I believe. Now this point, so whatever the output that we have got here, loop detected at the node 5, so the slow and the fast pointers met at the node 5, confirming a loop exists. So what is loop removed, loop started at the node 3? This one, this is nothing but loop was starting at the node 3, it was removed by setting the previous nodes next to none. So this is also fine, I believe. So the final one, this one none, 1 2 3 4 5 6 6 to none. So this one final linked list printed without the loop. Traversal is safe now, right? So we have got the desired output and the algorithm works absolutely fine, right? So there were some indentation issues, so that I've corrected basically, right? Now the algo works absolutely correct, or the code works absolutely correct, right? So we are done with the detecting and removing loop in the linked list algorithm, right, by making use of the another algorithm, this one Floyd cycle detection algo, right? So this is fine, I believe. Next, yep, we are left with only one algorithm. Next we'll be discussing the cloning linked list with a random pointer, right? Cloning the linked list with a random pointer algorithm in the linked list playlist basically, right? So this is it for the detecting and removing the loop in the linked list, right? So let me summarize whatever we have learned so far. Just listen to this, or just remember these 3 to 4 points, man, right? So loops in the linked list can cause the infinite traversal, right? Again, loops in the linked list can cause infinite traversal. And the second point here is Floyd cycle detection efficiently detects the loops using the 2 pointers, right? So this is important. Again, if you don't know, we'll be making use of the Floyd's algorithm in the linked list many times. You have to know that algorithm. So this is the first algorithm. If you don't know, you can just go through the video, or I'll be uploading the same thing in the GitHub as well. You can just go through it. So Floyd cycle detection efficiently detects the loop using 2 pointers. After the detection, loop start is found and broken to remove the cycle, right? So the time complexity would be big of n and the space complexity would be big of 1 in this case for this particular algorithm, right? So we are done with the coding part, right? So we are done with the coding part here. So so this is it for now, right? Thanks for watching, guys.